Hi all. In this example, we're going to divide 15,079 by 32. Talk about what that means and what we're really trying to accomplish when we do that. So writing out the familiar long division problem. I think most of us learned we're going to try to take 32 into the smallest part on the left-hand side of this number that we can. So 32 doesn't go into 1 or 15, but it does go into 150. It goes into 150 4 times. Then I'm going to take that 4 times 32, multiply that out to get 128, and then subtract that 128 from the 150, and see that the result of that is 22. Then I'll bring down the rest of the number, the 79. Some of you may have just brought down the 7, but either way. And then see how many times the 32 goes into 227. And it goes in 7 times. Then we'll take the 7 times 32, and that'll give us 224. Subtract the 224 from the 227, then I'll be left with just a 3 from that result, and we'll bring down the 9. Looking at how many times 32 goes into 39, well, we should see that it goes in 1 time. 1 times 32 is 32. Subtracting the 32 from 39 gives us 7. So our answer is something like 471 with a remainder of 7. Now, of fundamental importance here, and this is the biggie, what the heck does that mean? Well, so I did all of this stuff over here, and hopefully you followed where these numbers came from. May have been a while since you've seen that, but that should look familiar. Well, what this means is that 15,079 can be written as 32 times 471 plus 7. Now each of these terms has a specific name here. So let's look at this. The 15,079 is called our dividend. It's the number we started with. The 32 is the divisor. The 471 is the quotient. And the 7 is the remainder. Alright, but what we're seeing is with this division algorithm, that is, this process we used over here, it's called the division algorithm, or by some people, it's a division algorithm, we get a unique result. 471 is the right number of times that 32 goes in here, and we have a remainder of 7. And this remainder, this is important, it's always less than 32, but greater than or equal to 0. So every time we come up with a remainder that fits that, that is, it's less than the divisor and greater than or equal to 0, we will uniquely come up with a quotient that fits with that divisor for a given dividend. That is, this is the right answer, and it's the only right answer, which is kind of nice. We like that in math. Another way to write out this result is to see that 15,079 divided by 32 is equivalent to 471 plus 7 divided by 32. And I want you to recognize that these two things are equivalent with real numbers, and we'll talk about what it means as we look at other kinds of structures. But this is what division looks like, is this process. We started with these numbers, the 15,079 and 32, and we ended up with the 471 and 7 as what those led us to. I'm going to look at this example in a slightly different way in just a second, but I want you to focus on making sure you understand where what these numbers mean here in the problem. And I want to add to this is this method we just used here came up with the right result, 471 as the quotient and 7 as the remainder. There are other ways to do this, and any correct way that gets us to this result every single time is a good division process to use. So we're going to look at another one real quick that looks very, very similar and hopefully adds to some understanding to what it is that we're doing and will help us to do polynomial division. In example 2, we're asked to divide 15,079 by 32, and I'm going to use a very similar process that hopefully can explain a few more of the steps that we're seeing. The process we're going to use in this problem will be extremely similar to polynomial division, and that is, I want you to see this as the same sort of process as the long division, that is, polynomial division has the same sort of process as long division you've seen before. But looking at this, I should notice that 400 times 32 is smaller than the result of 15,079. Now let's actually multiply that out. Multiplying 400 times 32 gives us 12,000, 800. Subtracting that result from 15,079, I'll get 2,279. And that should look pretty familiar. Looking at, well, that was the biggest hundreds. Looking at the biggest tens place, we should see that 70 times 32 is less than this amount, and in fact is 2,240. Subtracting that off of the 2,279, we should see that 39 is left. There's 132 in 39, and that leaves us with a remainder of 7. The way that I've written this here hopefully was meaningful to you, but what we're really getting at is that the quotient here should be 400 plus 70 plus 1. And if you look at the process over here, this looks almost identical to what you had up there, except I've included a few zeros. I think this adds some meaning to the process, but importantly, you need to recognize that to get this quotient, we're just adding those values together. And that's exactly what our polynomial division will look like. Hope this helps.